Hi, this is my demo for the closest pair of points project. I implemented two algorithms. One is brute force and the other one is divide and conquer. Um and they compare them to the real runtimes. And first, I'll start with the algorithms file. At the top, I defined a small data class point with x, y, and index. I use the index so both algorithms return the indices I and j on the closest pair as required. I also kept a helper to command squared distance that avoids expensive and square roots and keeps comparisons fast and exact. The brute force function is straightforward. It loops over every pair of points, updates the best distance if it finds a smaller one, and returns the two indexes that achieved the minimum. This matches the theta and square behavior we learned. And the divide and conquer has a class pseudocode: sort by x, split into left and right halves, resecure on each side. uh, Take the better of the two results, build the center strip around the split line, and scan only a few neighbors in y order. That's the packing argument that keeps the merge step liner. Finally, return to the two indices for the closest pair overall. This yields the theta n log n complexity. And if there is a time distance, I return the lexical graphical smaller index page, so outputs are deterministic. And next one is experiment. um, this is the experiment driver. I test 10 input sizes using the alternative range 10,000 to 55,000 in steps of 5,000. For each n, I run m is equals to 10 iterations and compute the average time. I generate distinct random points and use the same input for both algorithms, so the comparison is fair. All results are written to CSV file in the result folder, so we can plot later without rerunning it. So this is the folder, and these are the result folds. So this is the one. All result empirical CSV has n and the average measure time for each algorithm, and the results predict CSV has n and the predicted time computes from algorithm 1 and algorithm 2. In the next one is plot results. This script leads both CSVs, joins on n, and makes three graphs with visible data marks, no smoothing. And the graph 1 compares the empirical runtimes of brute force versus divide and conquer, and the graph 2, uh, it's algorithm 1 of empirical versus predicting, brute force empirical versus predicted. And the graph 3 compares empirical versus predicted, divide and conquer empirical versus predicted. And they are also saved to the result folder, so I can just show you without rerunning it. And that's a graph 1. It shows the comparison of a brute force versus divide and conquer. And the second one, it shows the brute force empirical versus predicted. And the graph 3, it shows the divide and conquer empirical versus predicted. And I also wanted to show you the sample code. This was the command I used for the full experiment. I'm not rerunning it because it's gonna take so much of time, but the everything is saved to everything. So this is the command that I used for a full project. Till the results come, I'm gonna tell you about like these are the results. Actually, these are the commands I used. This is the command I used for getting this project done. To summarize, brute force behaves like n square, divide and conquer like n log n. The data and the predicted curves match what theory says. The code runs index pairs as required, uses m is equals to 10 iterations, the alternative n range, and saves CSVs and plots for grading. Thank you for watching.